Well, welcome everybody. This is the second kickoff meeting for the ICE Plus training course. Our role here today is to introduce some of the instructors and also to go through the syllabus and hit on any points that we may not have managed to get across to you through emails, and also, I guess, answer any questions you may have. A number of our instructors are on today. I say a number, a small number. I'm Gareth Funning. I'm a professor at the University of California, Riverside. I study INSAR of earthquakes and continental deformation. I've been doing this for about 20 years. And last time we did this, I made everyone say what the first interferogram they processed was. And for me, it was the Manyi earthquake in Tibet in 1997, which I did for my first project of my PhD. Franz, would you like to introduce yourself?
Sure. My name is Franz Meyer. I'm sort of co-chairing this UNAFCO training this year with Gareth. I'm in Fairbanks, Alaska at the University of Alaska Fairbanks. Easy to remember, I guess. And I've been in Fairbanks since 2007. I'm teaching remote sensing, predominantly microwave remote sensing. And I'm also associated with the Alaska Satellite Facility that some of you may have utilized in the past, services such as our search clients and our maybe on-demand services. We'll use data from ASF in this training, mostly data that was created by JPL and is archived at ASF. I guess my first interferograms were created maybe around the year 2000, 2001, working on analyzing the Russian Arctic and glaciers in the Russian Arctic for change in dynamics and extent. And that was what my PhD was on. And back then you could do a PhD with like 15, 20 interferograms. In this course alone, you'll have hundreds of interferograms that you will touch. So a lot has changed, and hopefully you'll benefit from the data sets that are available these days and software tools that you'll learn about in this course in your careers.
Thanks, Franz. Paul, would you like to?
Yeah, hi, everybody. I'm Paul Rosen. I'm from JPL. I have been here for many, many years, since the 90s. And if you go back to my summer student days back in the 80s, right now I'm the project scientist for a mission called NISAR, the NASA ISRO SAR mission, which will launch hopefully in about a year and a little bit, and will produce prodigious amounts of data, even more than what Sentinel is producing, that you'll hear about in this course. And this course that you're taking should prepare you very well for the use of those data if you're interested in dense time series and space and time. So my first interferogram, since I've been doing this forever, was back in 1992, using ERS data to study the Landers earthquake and whatever other data we could get our hands on back then. As Franz said, in 2015 interferograms was enough to write a dissertation. In my day, just one interferogram was enough. That's what we focused on, just trying to understand, develop the prototype techniques which have been built upon to make this class semi-automated tools, shall we say, for large volumes of data. So I hope you enjoy the class. The two lead instructors, Franz and Gareth, have really done a great job putting this together. So I'm looking forward to it as well as you. I hope you are.
Thanks, Paul. Emery?
Hi, everyone. My name is Emre, and I'm in JPL, just like Paul, but I've been in JPL for 3 years now. And my first interferograms were NVSAT ERS interferograms on North Anatolian faults, which did not lead to a publication or dissertation at the time. But I can say it was about 100 interferograms that would get you a good standing point at that time. But yeah, I will be here as a TA, so I will be joining only the TA hours, and I'll be happy to answer your questions. Welcome.
Thank you. Becca, I saw you were on.
Yeah, hi, my name is Becca. I'm a PhD candidate at the University of Oregon. I'm also a TA and I help a little bit with the logistics of the course. So yeah, my background is primarily in SAR and remote sensing over different volcanic systems, primarily in the Cascades. And my first interferogram was like, I guess 5 years ago at this point, which is Tolica in Nicaragua. It was a volcano and I made a stack of interferograms for it.
It's very modern, making stacks. I see that Forrest is on.
Yeah, hi. My name is Forrest Williams. I will be helping out in a TA capacity, and I'll also be helping to instruct the pixel tracking module that we're working on. I am a research software engineer at the Alaska Satellite Facility where I work alongside Franz. And my first interferogram would have been about 4 years ago, doing a tutorial, and I ran it for I believe, the Kaikoura earthquake.
Fantastic.
And didn't Imre and Becca and Forrest, didn't you all take this course?
Yes.
Is that true?
I took it in 2013, so it wasn't exactly the same one, but
Okay. Yeah.
it was an ISCE course, yeah.
Yeah. So some of the instructor team came through this course. So maybe in the future you can instruct too.
I think that's everyone, isn't it?
We have Melissa, of course, who's a very important member of the team.
Hi, Melissa Weber, Community Engagement Coordinator for UNAVCO, and I do all the hosting of the short courses and workshops, and yeah, that's my job.
Keep on task and send lots of emails.
Yeah.
Yeah, watch for emails from Melissa. They are always important with like links and information for this training. So it's the most important emails to watch this next week.
Fantastic. Okay, so shall we get on with looking over the syllabus? I can share my screen and show you guys. Hopefully you've all received an email from Melissa in which this syllabus was linked, and also we have placed links to it in the Slack channel for the course. It's pinned in the general channel, so if you haven't found it, you can go look there. Let's see. I'm going to share my. So hopefully you can see my my web browser here. If you go to the general channel and you click on in Slack and you click on pinned, you'll find a link to this syllabus document right here. And I have it open here. And this really has been updated and it's a living document. So whenever we realize we left something out or something needs to be slightly modified, we'll update the Google document. So from now on, this document is really what you should refer to for information about the course. So it starts with a list of the instructors, and the next thing is the course overview. And what really this says is that the course is divided up into several parts. Before COVID and well, really just before COVID, we used to hold this class as an in-person class. It would have 8-hour days and it would be in person in Colorado at the UNAVCO headquarters. Of course, with COVID, we couldn't do that. And so we decided to still hold the class and hold it in this online setting, but that meant that we couldn't really have 8-hour days. I think it would have killed everybody. So what we decided to do was to take some of the more foundational material and put it into this pre-course, which is running sort of this week, and make it more self-directed. So we have the pre-course now online and at your own pace. There is also a survey that goes with that. Again, Melissa should have sent you an email about it. We would really like you to fill out that pre-course survey. And it's a series of questions about SAR and INSAR, and it's to gauge your background knowledge. And the goal is not to get a perfect score if you don't know the material. It's to get it's to show what level of knowledge you have coming in, so that we can assess how much you learned during the course. So please do take it if you haven't already. It's really useful for us for our sort of assessment of the course. Following the pre-course is the main course, as well. The main meal that will be next week, and we will have 4-hour sessions every day for 5 days. The time slot is chosen to be attendable by most people who are registered. I'm sure it's not perfect for everybody, but you know, we understand we're mostly based in the US, and so that's the time zone that the course is being held in. Those live sessions are recorded, so if for whatever reason you miss some material, at the end of each day we will convert the video feed to and upload it to YouTube. So it should be accessible to watch after the event, for if you want to go over things again. And in those,
maybe briefly, so for the 4 hours, or maybe you were about to say that I think the first hour is predominantly homework discussion. So you know, every day you'll get some interactive homeworks to complete. Those are not overwhelming, but they get you to run through certain notebooks that we show you and produce certain results. And then in the morning we have the first hour. Mostly we talk about you know, issues that you might have with homeworks. Maybe some, you know, 1 or 2 of you gets to present some results, and then we have 3 hours of new material. That's sort of how it's built.
Thanks, Franz. And yeah, most of those live sessions of material will be the instructor going over usually Jupyter notebooks, these interactive Python scripts, basically, that are real code embedded in them that you can run, and the instructor will try and explain, you know, what the purpose of the code is, what it is doing, and how it works, and how to run it. And you can follow along with us as we do that. There is supplemental material that goes with the course. This is stuff that was in the course before, but for one reason or another we can't offer this year. But we have the recordings and we have the notebooks for those. So one example is that last year we had an instructor, Brent Minshew, who offered some material about glaciers. Brent Minshew and his colleague Brian Reel. Brent and Brett are not available. Brian are not available this year because they're working on real glaciers in Iceland. But we have the recordings, and so if you want to go over that sort of thing yourself, it's there for you to do that. We also have, after the course is done, a second survey to assess, you know, not only how much your knowledge has changed, but also what you thought of the course. And of course, that's also very important to us to know how we did, and then what we could do to improve in future. The majority of the exercises, as I mentioned, are involve these Python notebooks, and they use a system called the OpenSARlab. You probably have seen some emails about this. If you look in the syllabus, we talk about it a little bit too, but it's very important that you register for this now, basically, so that you can make use of all these pre-course materials, and that so that you're set up to run the exercises next week. Yeah, and so to register for OSL, you can click on the link that's in the syllabus, and it will take you to a place where, you know, if you do this, I think I've already done it, so that you're taken to a web page, and if you haven't registered before, you have the opportunity to register when you do that. And when you register, please use the email that you used to register for the course in the first place, because the server has a list of email addresses that are approved already for the course by registering, and so you have to do that. I see a question in the chat, which is, so the idea is to fill the pre-survey before getting deep into the pre-course. That is correct, yes. Please do. Please do it now. And if you don't get 100%, don't feel bad. I'm not sure I could without for every single question. Some of them make me think, definitely. And if you don't know the answer, then at least we should try in the process of the pre-course and the course proper, trying to address some of those.
Yeah, and you know, those are the survey is less an assessment of you and more an assessment of ourselves. By giving you the same questions before and after, we have a way of sort of figuring out which of the content worked well and which of the things we told you didn't work so well, and it gives us an insight on which modules we have to improve in the future. So we have basically questions that relate to each module of the training, and that allows us to figure out, you know, which stuff was clear and which of our materials wasn't so clear.
So back to the OSL, I'm curious amongst our attendees, how many of you have successfully registered for OSL? Give a thumbs up in the Zoom. Well, if we had a session on how to do this on Monday, but if you missed that session and you still are curious how to do this, on the syllabus we have linked to a video. This is under pre-course content, accessing and working within the OpenSARlab. If you click on that video or that link, you get a video of France talking and various other people talking about how the system works and how to register for it. So that would be a good place to go if you're not sure what you're doing. And it also talks about how the internals of it work and how to navigate around it and where the notebooks are and that kind of thing. That's all very useful background. Please make use of it if you're still in a situation where you haven't got it to work yet.
Yeah, and I just put the link in chat, so if you haven't registered yet, please click on that link and register for the platform.
Great. So what else we have in here? We have some information about homeworks. This is another, we're back in the course overview section of the syllabus. This is another sort of follow on from having to push this course into online into fewer hours. So now, rather than having sufficient time within each day's exercises to completely finish some of the things, some things are being left for you to finish on your own. And we would like evidence of you finishing them as homework, basically. So you complete the exercise and you can save the notebook output as a PDF and use that as evidence that you finished the exercise. And we've set up a Google Drive, a shared drive that you can access and upload your results to. There are instructions, they're also linked within the syllabus about how to set up your own folder within the shared folder so that your stuff can be separated out from everyone else's. We know that this stuff is yours, and that's where you would upload your PDFs of your homeworks. Some of the homeworks are sort of doing some of the same sorts of tasks, but with different data. These are all documented in the various days of the syllabus. So going on to the next section of the syllabus is just links, including links to most of the important things for the course. For example, there's a link to OpenSARlab, there's a link to the YouTube channel where the videos get uploaded. There's the homework instructions, the homework folder, a place where we save the chat from the various sessions that we have. The pre-course survey is linked here. The website on the UNAVCO webpage where you registered is here, and the Jupyter notebooks that we use. If you ever wanted to go and download them yourself to your own computer, this is where they are. And of course the Slack channel, which is the main and most probably most instantaneous and useful way of asking questions when we're not on Zoom is also here. In the pre-course content, we have a series of things that are linked here or described here that we'd like you to go through before the course is running, including the kickoff meetings. We'll put the video for this meeting there eventually. The survey is linked here as well, and then a series of different modules that you can go and run on the OpenSARlab and get through before the course starts. So there's one on math, sort of foundational mathematics that you need to have a better understanding of what we're talking about. There's one on Python, a series of very basic notebooks that take you through how Jupyter works and what goes on there, and some very basic Python syntax and a few of the libraries that we use. Hopefully that's useful. The third one is accessing the OpenSARlab. That would be watching the video I already mentioned, and making your account and making sure that you can get in there, run a notebook, and get out. There's a notebooks on geographical information science using GDAL. GDAL is a series of very useful libraries that allow you to manipulate geospatial data. There have been a few updates to those notebooks this year because of changes in access to some data. And those three will allow you to do very simple manipulations of data, like reprojection, translating to different data formats and that sort of thing. I see a question, where can I find math evaluation? The math is on the OpenSARlab, module 0.1. And if you're able to log into the OpenSARlab, then you can go to the folder that's called Geosync and then click on that. And then inside Geosync, there's a folder called UNAVCO 2022, which is where all of the notebooks for this course are. And the notebook itself has a series of questions embedded within it that you have to answer as part of the assessment of that notebook. Where were we? Data search and access is the next exercise, and in this one we have added a very important notebook, which maybe you want to do before all the others actually, which is setting up required accounts with NASA and with Open Topography that allow you access to data. And you have to basically set up an account with NASA. You have to agree to a set of agreements as a result of doing that. And once you've made all those agreements, you have to make you have to run the notebook and make a couple of files that then will live within your OpenSARlab instance in your file system that will allow you to automatically download digital elevation models and other things that, like SAR images, that you need to process interferograms. This notebook also gives you some guidance into how to search for data using a tool called Sacera. So if you get that one done, then what we have left is SAR theory, both a sort of in-depth one, which is optional, which goes really into the details of how SAR images are collected and processed, and a second one, which is more in terms of the phenomena or the capabilities and some of the potential drawbacks of SAR imagery. And of course, SAR imagery is the kind of the building. It's what's the input into INSAR. So of course, understanding how the images are, what affects image quality and various things like that can read right into what you can do with INSAR. Any questions about the pre-course?
Gareth, maybe I can jump in here real quick and Becca, maybe once the recording is done, we can take what I'm going to say and make it a little separate video. Some folks had issues for the pre-course work and for some of the notebooks later. When we ask you to hand in your homework, we will ask you to print the notebook to a PDF and hand the notebook in. And some folks had issues finding out how to print the notebook. Let me just show you real quick how you can do it. I know of 2 ways, and maybe other people know of more. So let me just share my browser real quick. So once you are, let's assume that this is a notebook that you worked on. Actually, I'm giving away Forest's glacier tracking notebook here already a little bit, which you will see later. So let's assume that this is the notebook that you've completed and you want to submit it as a PDF. There's 2 ways of how to do it. So, you know, once you are on the OpenSARlab platform, this is what the interface will look like. To print the notebook, you can either go at File and Print. And it's going to take just a second. It's going to render the notebook as a PDF like this. And you'll see that you have, you know, all the outputs saved in the notebook, which is what we want, so that we can look at your work. And you can then just click on Save and it will print it as a PDF. So that's one way of doing it. I did see on Slack that for some people in certain browsers that didn't always work. Another way how I know to do it is if you have your notebook open, you can do Control P. What is it on Mac? Is it
Command P, I think.
Command P probably?
Yeah, it's Command P.
And so that will also get to the same result. So either do Command or Control P, depending on what computer you're using to get to print, or you can use the file browser system, the menu item here, File, Print, and both of those should get you successfully to a PDF that you can then download and save on your local machine.
Super. Any more questions about pre-course?
Yeah, I mean, could you just try to print the Jupyter notebook from the math basic? Because even though we like do answer the questions, if you try to print it out, it doesn't work.
For the math basics?
Yeah.
Is that Paul getting all clever with his embedded questions?
So this one you can't print?
I think the question was, what happens to the math questions? You can run the notebook through to like the first question and we'll see if you can print the answer.
Yeah, I mean, even though if you answer the question, if you try to print it, there is still like visible code, not the answer.
Okay. So I actually didn't read the question, so if
you run it down, yeah.
I'm just assuming that I say yes, A, which probably is wrong. And then it does check.
Wrong.
I was wrong. Which is fine. Again, I didn't read the question, but if I do a print now, you say that it doesn't print the answer. Let's see here. Aha, the figure didn't print. Interesting.
What about save and export notebooks?
Yeah, you can do that too. I mean, if this fails, you can just alternatively submit the notebook. So if you save the notebook with the save button, and then you can either print or download the notebook. That's another option.
There's also an option under the file menu to save and export it as a PDF, right?
Garrett, that doesn't work.
Yeah.
Okay.
That one has some, I think this one is also printing this way because it has like LaTeX code in it. So the LaTeX code is printing as is, and that's why we can see it.
Let's see what this does here. So also the Control P. Oh, it doesn't. It's the math notebook. Interesting. So I would suggest one of 2 things. If you want to make sure that your questions are saved, you can take little screenshots and submit those. You have a name sort of in the homework Google Drive, you will create a folder with your name, and then in there for homework or for the math basics, you can just submit the little screenshots of the answers. If you want, you can do that also.
A suggestion.
Or alternatively, you can download the notebook and just submit the notebook.
There's a good suggestion in chat, actually, that you can just add a cell and say what the answer is.
Yeah, you can do that too.
You want to demo that?
Sure. So you can, if you, let's assume that you know what the answer is and you're not like me, you can click this little plus up here, which adds a new cell. And then you can, you know, I would, if you have text answer, you can turn that into a markdown cell and say, you know, my answer to this question is A.
And it's wrong.
And it's wrong.
Yeah, so that would be an elegant solution if you
I wonder why the math one has this issue. Maybe it's, yeah.
This
Interesting.
worked last year. I don't understand why suddenly it's not working.
Yeah, maybe that's a new feature in Jupyter Lab.
It's the NB convert, the notebook converter code. They updated it, and now you have to install MikTeX or MacTeX independently from that. So like there's some dependency issues that has caused this to fail. So it's the LaTeX code part, the LaTeX formulas are the ones that are breaking it.
Is that so? That's a Jupyter Hub problem.
yeah.
Kind of, it's this NB convert package that comes with the Jupyter Hub or Jupyter notebooks. So they are not supporting Python 3.10 at this point, but we are not using it either. But they also had other updates that broke some stuff.
Okay.
That used to work.
That sounds like a problem that you could fix potentially then, Brans.
Yeah, so if you Imre, could you put that in the instructor chat, and I'm going to talk to Alex about it and see if there's some way of fixing it.
Yeah, sure.
Thank you. Sorry about that.
If that's the case, it's not just for the math notebook. It would be for all notebooks.
The SAR one, definitely.
Yeah, let's look at the SAR one.
Anything that uses, yeah, LaTeX. Oh,
it is true that SAR doesn't come without equations. So let's see. So this one.
and just for this one, it used to work in
This one may
pages, right? It used to be, they used to be rendered as slides, and it doesn't seem to be an option anymore.
Well, there are, they're getting rendered. Oh, the rise is still in there, and I can look that up too, how that works. But let's print this real quick and see what happens. This may take a while because there's lots of graphics. Oh yeah, something's breaking with the graphics. Oh, some work.
There's a video.
Okay. Yeah, so we'll look into that. And so if the figures don't print in your PDF, that's not a big deal. You know, the figures that are already in the markdown cells, as long as your outputs print, which it seems to be the case here, that should be fine. But if the equations don't print and your answers don't print, then we'll fix that. So I'll talk to Alex about it.
Super. All right. Assuming that's all of our pre-course questions, we can move back on to looking at what we're going to talk about next week. So for the syllabus is set up in a way such that every day has its own page, and there's a list of what we're covering and what the goals of those things are. And then at the bottom, there's homeworks. So what we would like you to take out, to carry on working on once we're finished for the day, talking to you. So day one, mostly we'll start with introductions. Most of the day is taken up with a mixture of kind of the end goal, in some sense, like what we would like you to be able to do, or what the purpose of processing INSAR data might be, which is to actually understand something physically about the Earth. So we'll go through a little bit of a few exercises on starting with me lecturing about how we make models from geodetic data such as INSAR. And then France will have a module using real data from a volcano, showing deformation of the volcano and what we can learn from that and how we model it. Moving past the mid-session break, then we'll have Paul talking about INSAR theory, followed by the first interferogram processing, which will be using StripMap app, and Eric Fielding will lead that. And StripMap app is something that will take data from StripMap satellites, like, for example, we're using data from ALOS, which is the Japanese L-band satellite, the first one that they launched of that family. And because we have limited time, you'll be asked to finish that notebook as part of homework, for example. And as we've already discussed, what we would like to do with the outputs of these notebooks is save them as PDFs. Day 2 is mostly dictated towards processing Sentinel data. So we'll have 2 sessions on that. But in the morning, we'll have at first review of homework problems and discussing any issues that were encountered, just as we did with the pre-course material just now. That's kind of what we'll do. We'll ask students or participants to share their screens and show us things that aren't working if they're not working, and we'll try and find solutions to those problems. And there's also a module on interferogram interpretation, in which we'll look at a real interferogram of an earthquake from Turkey and try and understand what the fringes mean, and actually try and unwrap the data, so convert it to a continuous signal, which is something that computers do these days, but they don't always do it correctly. And so it's useful to have some intuitive understanding of what it is you're looking at and what the answer should look like, so that you can assess whether an interferogram has been unwrapped correctly. Also note that I didn't point it out for day 1, but it's clear for day 2 that we have office hours twice a day for most of the course. We have them in the morning for people for whom this time slot is, or an earlier time slot is more convenient, and we also have them late in the evening for people who find that more convenient. And those are more opportunities to raise your problems with us and get help. We are not there to teach you things necessarily. We're not there to lecture at you during office hours, but we're there to, there'll be several of the instructors and TAs available to try and solve your problems. On day 3, what have we got? We have a session on actually preparing INSAR data for modeling, and how models render into INSAR line of sight. So how we do that. We have a module on time series theory. So this is kind of building towards the sort of the second big concept of the course, perhaps, which is INSAR time series and all their capabilities. And we have a module on downloading and preparing interferogram stacks, which are the inputs into time series software. And we use a set of tools called ARIA tools for that. Day 4, we have, we'll start with a brief overview of SAR imaging missions. So the different satellite missions that are out there, because it's very useful to know sometimes what other data you might be able to get hold of for problems. And we'll talk a little bit about ionosphere and troposphere corrections, which are ionosphere and troposphere signals are the biggest sources of uncertainty in our data. I guess some people actually go out looking for these, but for us, they're noise. Anyway, there are ways of estimating those signals, and if you're not interested in keeping them in your data, removing them from the data so that you can use the data to study Earth surface things. We have a new module that France demoed very, very briefly. That's going to be exercise with him and Forrest on using Auto Rift, which is a tool within the ISCE software suite that allows you to measure offsets or movements of the ground using image correlation, not using interferometric phase. And that can be useful in places where INSAR doesn't work quite so well. It's particularly useful for fast moving things like glaciers and landslides. And we'll finish the day with a module where we look at taking the output of INSAR data of various sorts from different viewing geometries, from ascending and descending tracks, for example, and trying to extract information that's more intuitive to us. So INSAR measures only deformation in the radar line of sight, the direction that the satellite is pointing at the ground, but we tend to think of things in terms of vertical movement and horizontal movement, and we can actually extract those informations from the INSAR and actually convert the INSAR into something that's a bit more intuitive. And on day 5, we're focusing largely on time series processing, but we'll start the day with Paul giving us a brief rundown of what to expect from NISAR and why it's going to be awesome. Most of the day we'll be using the software MintPy, which is a Python-based INSAR time series processing software that is really powerful and really useful, and we'll try and get you up to speed with how that works and also how you can feed your own data into it. So those are the goals of the course. One more thing to mention about the course in general is that we do offer certificates and potential graduate course credit as part of the course. We'll issue through UNAVCO certificates if people complete the majority of the homeworks and both the pre and post course surveys. That's what it says here. The majority of the course homeworks means you have to do at least 6 of them, complete 6 of them, and also complete the 2 surveys. Then at the end of the course, we will prepare certificates for you. If you registered for graduate course credit, you had to do this separately from any of the sort of the registration stuff you do with UNAVCO. You actually have to go and pay money to the University of Montana, who offer this, and if you haven't done that, then you're not going to get this credit. But for that, you have to complete all of the homeworks, and we'll also grade them to make sure that you got them correct, you did them correctly. And if you did 7 of them correctly out of 10, and you complete the pre and post course surveys, then we'll issue you graduate course credit. So anyway, all of that information is in the syllabus, and go there and read more deeply if you're interested in answers to some things. And of course, if you have other questions, you can post them on the Slack channel and under questions, this channel here. And several of you have been doing this already, of course. And that is the best place to get your questions answered in a timely fashion. So that's all I had to talk about today. Has anyone else among the instructors got anything they want to say? And if not, we can open it up to general questions from participants. Has anyone got any questions? Feel free to unmute yourself and ask. Even turn your camera on if you want.
Maybe a short note, Gareth. In the syllabus, it might be worth us putting in, like, first thing in the morning, a note to sort of restart service. So OpenSARlab is a cloud-based platform. It actually pulls in all of the instructor materials that you have available from a GitHub repository that Paul Rosen has set up a year ago. And it may be that instructors here and there make updates to the notebooks as they prepare for their lectures. And so OpenSARlab actually picks those up automatically every time you restart your server. And so to make sure that you always have the latest code, we should probably remind everybody every morning to, as we start talking about homework, so I go into a short break, to quickly restart your server to make sure that you have everything you need to go through that particular training. It might be worth putting in a short note in the agenda every day so that we don't forget about it.
You're going to destroy my beautiful formatting.
It is beautiful formatting.
Put it somewhere. I think we can do that live and just say, hey, everybody, because we're still working on minor fixes right up to the end.
And the other thing we should do is, if maybe early in the week, maybe sometime on Monday, maybe we can find just a minute for all of you to briefly turn on your cameras and take, one of those infamous Zoom, group photos. We tend to do that sort of the closest we can get to an actual group photo these days. But
I think we can put Melissa in charge of that.
Yeah,
she did a great job last time.
So be prepared on Monday to briefly, if you can, turn on your camera to help us out with a nice group photo.
Questions? If there are no questions, then we could stop recording.
Yeah, maybe last thing. So there is another office hour that we'll offer tomorrow. The office hour will be at 9 a.m. Pacific time. You should have seen that from an email from Melissa. We'll remind you about that either late today or early tomorrow morning.
Is there any chance for an in-person course? Well, potentially in the future. It's tricky, right? So we offered this course as a virtual course, and for the first time totally virtually 2 years ago, and we realized that we could reach so many more people this way. So on the one hand, the in-person course allows us to go into real depth, but also only that kind of real depth with a much smaller group of people. And that is something for discussion, like what we would like to do. I think we would like to continue this kind of format for the kind of the broad reach. Whether we also offer a smaller course in person in the future, it's possible, but we might.
Yeah, if you have thoughts on that, I mean, in the post-event survey or you can give us that kind of feedback. For some of you, I think the online format allows you to attend. Would be difficult for you to do it in person. But of course, we also understand that there's benefits to having an in-person training.
Another question is there any opportunity to use OSL after the course? Yeah,
so there's 2 ways. We will provide you at the end of the training with a Docker container, which basically is a self-contained version of OpenSARlab that you can install on your local machine. So it won't sit in the cloud, but all of the functionality, all of the notebooks, and all of the software will be available to you locally via a Docker container. So that's one way of how we can do it if you want to run it locally. If you want to continue in the cloud after the training, you can always contact me either via Slack or via email, and we can see if we can figure something out. But especially the more involved geoscientists, they like to have full control. So we will have a Docker container that allows you to do things locally. And it comes with ISCE and MinPy and all these software tools we're using this week pre-installed.
Any more questions? Well, we made it 54 minutes, so that's a good session. Thanks everyone for coming, and we'll see you next week, if not before.